Hello again, this is Galen Pickett, Physics 151, California State University, Long Beach, and now I want to concentrate on this frame of reference idea for an elastic collision. So here it looks a lot like the inelastic setup, but the final state has got, the definition for the elastic collision is that the change in the internal energy is equal to 0. So in the final state, I've got the possibility that particle 1 will go backwards, so I'll call it P1 is its momentum, M1. Particle 2 will reflect backwards with P2 momentum, and it's got a mass M2, but we've got to have still the change in the energy of the system is equal to 0. That's the energy principle. And the center of mass is sitting right there. That's the thing that allows me to deduce that these two P's in the initial state are oppositely directed. So the momentum principle will say in the final state, the momentum of the system is equal to the total mass, m1 plus m2, times the velocity of the center mass, which is 0. It has to be 0 because it started at 0, it ends at 0, and there are no forces from the surroundings. That's the momentum principle. Which means that P1 plus P2 has to be 0. So I could write, say, P2 as P final 0, 0. And I could write P1, that's the final momentum of particle number 1, as minus P final, 0, 0. So now there's just one unknown left. And now let's see what the energy principle says. The change in the energy of the system is the change of particle 1's energy plus the change of particle 2's energy plus the change in the internal energy. If we're doing an elastic collision, that has to be 0. And this whole thing is equal to 0 because there's no work from the surroundings. So I get 0 is equal to the change in energy 1's, particle 1, that would be, I look at what its final and initial kinetic energies are. So what I get is P1, I called it P final here, so P final squared over 2m1 minus P squared over 2m1. That's the final and the initial for particle 1. And then I add P final squared over 2m2 minus P squared over 2m1. And that has to be equal to 0. The only unknown there is P final, so let's work on this a little bit. I've got two terms with P final in them. One belonging to particle 1, one belonging to particle 2, so let's put those together. So I get 0 is equal to P final squared times 1 over 2m1 plus 1 over 2m2. And then I've got these two terms that involve P squared. I'll just put those together with a minus sign, and I'll factor out the P squared. 1 over 2m1 plus 1 over 2m2. And the only way I can get 0 here, notice I got a similar term here, I could cancel that off. What I get is P final squared is equal to P squared. So the way this elastic collision can go, the only way it can go, is minus P. These two particles just come in with momentum P, and they leave with momentum minus P, which is exactly what an elastic collision means.